Welcome to this public meeting between Omaha Public Power District and the Nuclear Regulatory Commission. My name is Linnea Wilkins. I am the Licensing Project Manager for Fort Calhoun Station. The purpose of this meeting is to discuss topics concerning containment, internal structures at Fort Calhoun. This meeting is for informational purposes only. No decisions will be made at the meeting today. With that, I'd like to start with introductions. Again, my name is Linnea Wilkins. I am the Project Manager for Fort Calhoun Station.
I'm Matt Highland. I'm the Director of Engineering and Senior Structural Engineer, Division of Engineering and Mechanical. And I'm Marty Murphy. I'm the Chief Mechanical and Structural Branch. Okay, Chief for Office on full oversight.
That's all we have here for NRC staff. I would like to ask if there are any staff from the NRC headquarters on the line. Anyone from the regional office on the line? Megan Williams. Any senior residents or resident inspectors on the line? Okay. With that, I'll turn it over to OPPD for their introduction.
I'm Brian Davis. I'm the Recovery Engineering Director. Bruce Rash, I'm the Recovery Director for First and Staff.
Could they speak up? It's really hard to hear you. You kind of start off strong and then you fade away.
I'm experiencing the same thing.
Okay, thank you. There might be in front of you. Thank you.
Russ Blackie, Design Engineering. Doug Steeple, Lesbian. Andrew Carmine, Automated Engineering Services. Eric Wickett, Regulatory Services. Eric Helmerson, Automated Engineering Services. Bob Finley, Central Structure Project Manager.
Congratulations, NPR Institute.
Okay, everyone, Sergeant of update. Next row, better contact the brothers.
Thank you. Are there any representatives from the licensee on the phone?
This is Don Ferrara from Exelon.
Lisa Olson with OPPD. Anyone else from the licensee represented on the phone? Okay.
My name is Deputy Director, one of the Division of Operators and Reactor Licensing Office, the Vice Chair of the
It is not required for the members of the public to introduce themselves. However, I know there are a few on the line. Would you like to introduce yourselves and your affiliation?
I'm Laverne Tran, public citizen person.
I'm Wally Taylor of the Iowa Sierra Club. Mike Ryan in Omaha with Clayton, Nebraska, and we have a really poor connection. It's really difficult to hear anybody at NRC.
And
Thank you, Ms. Ryan. I'll remind everyone here just to speak up a little louder so that the participants on the phone can hear clearly. Thank you.
and also
Lines.
and to let you know, I can hear those guys very well, and then the NRC guys, they start strong and then they fade.
Okay. Thank you.
Ditto here.
Are there any
Is there a way to mute our lines?
Are there any other members of the public on the phone that would like to introduce themselves?
This is Charles Austin with the Nebraska Green Party.
Okay, anyone else?
Brian Jelke from Sergeant Lundy is on the line.
Okay. And with that, I would like to ask the participants on the phone to please mute your phones during this meeting. As a reminder, this is a Category 1 meeting. So the public is invited to observe this meeting and will have an opportunity to communicate with the NRC after the business portion or before the meeting is adjourned. With that, I'll turn it over to Louise Lund for her opening remarks.
Yes, thank you, Linnea.
Pardon me for a minute. How do we mute and unmute our lines?
I believe it's star 6.
Okay, thank you.
Thank you.
Thank you, and thank you for that introduction, and welcome to all the participants of the meeting today. And we have, I think, a lot to cover in this presentation, and this is a very important topic to us to understand your plans with the containment internal structures. And we have a lot of staff members here very interested in understanding your approach, as well as folks from the region as well who listen to this as well in order to make sure we coordinate this review. So thank you for your willingness to come here to provide this to the technical staff here at headquarters.
Thanks, Louise. And I'll turn it over to OPPD for their presentation.
All right, good afternoon, and thank you for the opportunity to discuss the Fort Calhoun Station containment internal structure with the NRC and the public. I'm Bruce Rash. I'm the recovery director for Fort Calhoun Station. I'm responsible for the issues associated with the recovery of the Fort Calhoun precinct. Jerry Simpkins, the manager of licensing. Go quickly again through. Brian Davis will be facilitating for us. He's the recovery engineering director and responsible for this project. Bernie Van Sant is the project engineering lead. Tom Daly is the containment internal structure project manager. Russ Plaskey is the civil structural engineer for the station. Additionally, we have hired several leading industry engineering firms to support the containment internal structure work. Stevenson and Associates has developed the finite element model for the containment internal structure, developed conceptual designs to address issues, and supporting analytical work for the operability evaluation. Again, I'd like to introduce Dr. Sming Singh from Stevenson, Mike Allison, Doug Seymour, and Automated Engineering Services Corporation developed a topic model for the pipe rate pressure loads, which are used as inputs to the finite element model. From AES, we have Eric Halverson and Andrew Carmine. Sergeant Lundy is performing detailed containment internal structure design modifications, as well as the modifications to support removal and reinstallation of interferences for the structural members that will have to be installed. Additionally, they have done third-party reviews of the calculations and the analytical models, and PK Agarwal is here from Sergeant Lundy. We also requested MPR and Associates to do an independent review of our home approach, the design methods that we're using, the modeling approach, and to take a look holistically at our work to make sure that what we're doing is safe and meets the standards that are set forth in the documents that we're using. Carolyn Schleisman is here from MPR. I'm on slide 4. And we'll cover the agenda for the meeting, and then we'll get into it. As the primary purpose of this meeting is to inform the NRC on various aspects of our work. We encourage and invite the NRC to ask questions as we go along, and we have plenty of time to have the dialogue. We have the right people here. We believe you have the right people here. Encourage that discussion. If at any time you have a question, we'll pause, take the question. If we can't answer it, we'll get back to you with the answer. We'll work through that. I will cover the desired outcomes in a minute. Bernie Van Sant will cover the history of the issue and the discovery and extent of conditions as we know it. Russ Plackey and Doug Seymour and Andrew Carmine will cover modeling methodology, the licensing basis, the operability criteria. Then Brian Davis will cover planned actions for restart and what our proposed support is for NRC inspection activities and post-restart actions. And Tom Daly will cover where we're at with our current design options, and Bernie will discuss the modification analysis that's required to install the modification. And then I'll have closing remarks and whatever closing remarks from the NRC that we have. Okay, let's go to slide 5. First, we understand the importance of resolving this issue, and we want safety to be paramount in our path forward. So we are committed to the safe restart of Fort Calhoun. The topic that we're presenting today is the containment internal structure. It's the structure inside the containment shell that supports equipment and systems. It does not involve the containment shell or pressure boundary. Current calculations show that the internal structures are non-conforming but operable for outage conditions, and we continue to refine and evaluate the online cases. OPPD is determined to establish the licensing basis safety margins for the containment internal structure, and we're dedicated to support the NRC inspection activities for operability or restart. Brian Davis will detail proposed schedule and future interactions and ensure full access to all the information that the NRC needs to inspect, and he will discuss opportunities to go to our vendors, facilities, and to the site to support whatever inspection activities deemed necessary by the NRC to support safe restart installation. Slide 6. Today we have 3 primary desired outcomes. One is that the NRC's provided a full understanding and has an opportunity to provide feedback to OPPD on the containment internal structure operability criteria, that the NRC understands our path forward on the resolution of the containment internal structure issue, and that we're providing the NRC with a solid foundation on the problem identification, scoping, and resolution to support inspection planning and execution by the NRC. Now I'd like to introduce Brian Davis. Brian is the Recovery Engineering Director who's responsible for the Containment Internal Structure Project. As I said earlier, he will be moderating the presentation for us today. And with that being said, I'll turn it over to Brian.
Good afternoon. I'm Brian Davis. As Bruce said, feel free at any point in time in the presentation to ask questions. We'll start off the presentation with Bernie Van Zant, our Containment Internal Structures Project Engineering Lead. Bernie will step through Containment Internal Structures background from initial design through self-identification of the current issue, starting on slide 8. Bernie? Thanks, Brian. Good afternoon. Bernie Van Zant. My slide 8, I'd like to go through. The first thing I'd like to cover on there is give everybody a clear picture as to what structures we're talking about here. The containment has essentially 3 major structures that are involved. The containment dome and shell, which is the pressure boundary portion of the containment. Containment subcompartments that house the steam generators, the reactor coolant pumps, the reactor itself. And then finally, the containment internal structures, which is a multi-level structure that supports the plant equipment inside containment, which is identified previously. And the key that we want to get across is that this does not involve the containment pressure boundaries. The structure is separate from both the containment structure and pressure boundary and reactor subcompartments and steam generator subcompartments. Going on to slide 9, drawing showing the plant elevation of the 1013 level for the reactor building, containment building. And you you can see on the slide there, there's a grayed out area with the sub-compartments that house the generators, the reactor coolant pumps, as well as the reactor vessel. And then outside of that,
Looks like we got a difference in the slide deck on that.
okay, the presentation.
Do we have enough copies for everybody? I'm sorry.
The beams you see here, dashed lines, that represents beams associated with the containment internal structure, or that's a lot better. And as you can see, the containment shell and dome is not attached to these. They're supported by internal columns separate from the shell and the dome. Any questions?
Sure, I have one question to start off. You mentioned the pressure boundary, and I'm not intimately familiar with this presentation just yet. I'm going to listen very closely over the next couple hours. But the structure, the containment internal structures, doesn't that support a lot of Class 1 piping? That is pressure boundary piping? I mean, when you said this excludes pressure boundary, you're talking about the reactor vessel itself.
What I'm talking about, I would say pressure boundary is the pressure boundary for the containment.
For the containment, okay?
It contains glass components, which like main steam line, main feed, main injections that are safety related.
I think I was reacting to the opening remark where you said pressure boundary and didn't give it the context. But okay, thank you.
Thanks for the question. Okay, going on to slide 10, let's talk about the original analysis that we looked at. This issue arose. The original analysis was a hand calculation for this structure. It was done in accordance with the American Concrete Institute's ACI 318-1963 code. That was done with the load combinations that were identified in USAR section 5.11. That was what was submitted to the commission at the time of license of the station and was accepted. Since that time, we haven't done any major modifications to the structure that would have required us to go back and review these calcs and update them or change them where we would have had an opportunity to identify these issues. Going on to slide 11. The issue was discovered while we were doing an analysis for extended power uprate, or EPU. We were doing reviews of the system and identified that the temperatures of the piping for the component cooling water system reached higher temperatures during EPU conditions than they did during current operation. So we had to go back and look at the piping analysis for the component cooling water system, and we identified that we had some increased loads on supports and on the containment air coolers. The containment air coolers situated on top of the 1060 elevation of the containment internal structure. When we applied the loads to the structure, we went back and looked at the original calc, assuming that we would have no problem justifying these minor changes in the load. And what we found is that the loads on the beams, being 59 and 58, couldn't carry the loads that they were designed for, let alone the new loads that were going to be applied as part of the extended power upgrade. At that point, we initiated an extended condition investigation to go look and see what other areas may have similar problems with this internal structure. Moving on to slide 12. When we looked at these original calculations, we identified several issues with them. We had calcs complete. Some were missing. We didn't have calculations for all of the columns in the structure. Inconsistencies between the calculations and the drawings. Here are some of the calculations that we have were preliminary engineering drawings or engineering analysis, and were not the as-built analysis that represents how the plant was manufactured or built. And as such, we found additionally some incomplete considerations of some of the loads and some of these calcs, as well as did our extended condition, and started with B59 and B103. B103 was in the steam generator compartment. B59, as I said, was under the containment air cooler on the 1060 elevation. B59 did not meet its working stress requirements. B103 did pass. Given the fact that there's a companion beam to B59, which is that's on the opposite side of the containment air cooler, that beam sees the same loads and has the same stresses applied, and it also not meet the working stress.
Okay, another question. I could interject, please. You said B103 is in your steam generator compartment. You have replaced your steam generator, is that correct?
Yes.
And during that replacement, this would assume that you would have looked at the beam supporting the new generators.
Yes.
And this discrepancy was missed at that time? Not a discrepancy, but this...
This beam passed.
Oh, beam 103 passed.
Passed.
Oh, okay, I'm sorry.
Okay.
Okay, I thought you were identifying beams that did not pass. All right, thank you.
I've got a follow-up question to ask. That's Chris Benson. In the early 90s, Fort Calhoun initiated a safety enhancement plan as a result of issues associated with line basis control. And out of that, there was they called a DVD open item list. In that list, it was identified that several of the internal structures had efficient calculations or lines associated with them. Did you consider that in your discovery portion?
We considered it. The approach we had during the design basis reconstitutes, we knew we didn't have all the original analysis and the as-built analysis recovered at the time. The approach we'd taken was as we move along and do any modifications, we would go back and look at those. The assumption was that at the time of the issuance of the license, the original analysis that was as-built had been presented as acceptable. Based on that, go forward with the idea that if we modified it and touched it, then we'd have to go back and regenerate those analysis. Does that answer your question?
It does. My comment is really to the earlier opening remarks in that this was discovered this year according to C2 upgrade. However, there are open items from 1992 era that are associated with the same sort of design position.
Yeah, and when we looked at them, we didn't identify at the time that there was errors, mainly that there was lacking information that we could reestablish the original design basis. If we'd have identified errors, we would have had to have fixed them at that time.
Well, this is Marty Murphy. Why did you look at being one of those things? There's a extended condition, but what led you to that being from 58 to 59?
As far as I'd like to clarify. Did you say BE-103 is part of the steam generator compartment?
Inside the compartment.
Inside the compartment. If you go back to this slide that you had shown the problem, I'm not sure it's shown there or not, but
No.
is it part of the shaded area?
Yes, it is.
So the CIS, the way you were describing it, it's not just the dashed lines that you were describing before. It's the shaded area is also underneath it.
We looked at the shaded area to see if there was an issue there. Found out there wasn't. And that's when we focused back on the internal structures, got away from the reactor outside walls.
103 pass WSD.
I can't see how that would. We haven't done the detailed assessment. Have to do as part of the mod. I'm not seeing how that would have been.
Very unique for management.
Dave, I'm assuming you're going to go through deficiencies and describe it more, right? Okay.
Okay, very good. On to slide 14. We have the failure of beam 59 and its companion beam 58. We expanded the extended condition and did a smart sample on 9 heavily loaded beams in the containment structure along with the column. As we went through those individual beam assessments, we stopped after we got through the first 6 beams because none of them passed. Based on that, we determined that the stepwise approach of going through these one at a time wasn't warranted. Determined that we needed to go back and reconstitute the entire design of the containment internal structure using a three-dimensional state-of-the-art structural analysis. Next, Russ Plackey, Station Structural Design Engineer, will provide an overview of the modeling methodology used to perform the reanalysis of the containment internal structures, including measures taken to ensure the accuracy of the model. We'll be starting on slide 16.
Good afternoon, I'm Russ Plackey, design engineer for Calvin Station. First, just described to you what the CIS is, the function of the CIS, and also how the design discrepancy associated with the CIS were identified. What I'm going to talk about is the modeling methodology, inputs, and assumptions used for the redesign of the internal structure. A three-dimensional model of the CIS was created using strudel. The GT strudel is the state-of-the-art industry-recognized finite element analysis software that's used to determine loads on the structural members. This method of analysis more accurately reflects the loading on the structure as it analyzes the structure as a unit versus the original design, which analyzes each member individually and does not account for member interaction. The key input in the GT strudel model is the differential pressure. Differential pressure was determined using Gothic, which is also industry recognized modeling tool, and Gothic analysis will be discussed later on in the presentation.
The model in the whole connected structure, right? It's not just beam by beam.
Right. All the beams and columns.
That counts for redundancy in the structure, right?
Right.
Yeah, you'll see the model further on.
On slide 17, the analysis that was performed was very rigorous. All design loads and inputs and assumptions were thoroughly reviewed by third-party and independent reviewers. In addition, challenge boards, which was comprised of members of the review team, conducted rigorous reviews of the model and all the design inputs to ensure that all the critical parameters of the design were addressed. In addition to that, hundreds of hours were spent conducting
Lower intakes, no differential pressure.
Okay, thanks.
And finally, all the analysis and reports into the model have been rigorously documented and do meet quality assurance requirements. Inside, I'm assuming it's got rebar, right? How do you go about validating if there's adequate rebar? Or do you need to?
That's a bit more lead engineer would do. On the review of the engineering drawing, is full drawing the structure. So those full drawings are review on the design, which has and full calculating engineering was being have been excellent.
He needs to speak up.
Sorry, do I need to repeat that?
Yeah, I couldn't hear any of it.
So I'm Doug Seymour, lead engineer with Stevenson Associates. We performed a review of the full Calhoun engineering drawings and compared them against the actual construction drawings that we used to build on. And these were completely separate from the design, which we found deficiencies in. And based on that review, we determined that they're an excellent match. The full Calhoun engineering drawings are an excellent match with actual construction drawings that we used to on. So we're confident that, excellent.
Let me have a follow-up. So you're saying, I'm an engineer, there is a shop drawing, and they match.
They do. And so stock drawing is the same.
Okay. So don't consider rebar to be a deficiency. Calculation, I mean, there are two scenarios here. There's a calculation and the engineering drawing is not, they don't match, or the drawing and the shop drawing. Which one is it? I'm trying to modify that.
Well, as I'm sure you know, we have a problem with some of the initial design calculations. We have deficiencies in the ceramic there, but we have no reason that the structure was built per the drawings of the contractor.
The direct answer is the gap between the calculations and the drawings themselves. Is that correct, Doug? He asked about where the gap existed. It exists between the four detailed calculations.
I'm sorry,
That's where the gap.
So making an example, let's say abscess to number 10 of the beam, and your shop drawing
Well, as
shows.
right, no, but yeah, I think maybe, as Bernie mentioned earlier, in the calculations we have probably weren't the final design count. There was a document control issue back in that day, more than a design issue. Not so much that they should match and they don't, that we maybe don't have the final.
There's another thing we ought to mention. That's what they built it to, and that's what the QC oversight using during construction to make sure that it gets built in accordance with shown on the shop drawings, our fabrication drawings. So, confident that what we see out there on the design and field drawings are structure itself.
During the steam generator cut, the cubicle that the steam generator out.
My name's Tom Bailey. Cable Turtle Structure Project Manager. Been in the station for 24 years. Been not very. Yeah, model, and we'll start on slide 19. Doug?
Good afternoon again. Doug Seymour, lead engineer for the here. We developed the analysis of the containment internal structure. The model of the CIS is a finite element frame model constructing using the GT modeling software. The loads were evaluated within the model include dead loads, which include subway to the structure, equipment loads, commodity loads, anything that's permanently fixed. Live loads, which are transient loads associated with maintenance. Primarily, seismic loads, including both the operating basis earthquake and the maximum hypothetical earthquake, and pipe break pressure loads. The differential pressure is determined by input from the pressure model, which will be discussed. And the model evaluates seismic loads by using the seismic ground response spectrum.
That's a good question. Your USAR indicated that some of the operating scores were missile still. Do you consider missile load on the operating score with evaluation? Is that justification for that? Or?
We have load cases that are specified by the USAR for use the concrete beams and containment internal structure, and we use those combinations. Missile loads are not part of the requirements to be considered the USAR.
Well, you can continue.
Well, I got a question. I want to go back just so I understand. You said earlier, you said that you think that the design calcs you looked at were not the final design calcs, but that the field drawings and the pour drawings were correct. But the analysis you've used, that you're looking at now, I assume you're using as-built, so, and it still doesn't match, and it doesn't come out to be meet design. So going back to design calcs that you don't believe, what is that?
No. I mean, we're not going back to design calcs. We're using the as-built position, and we're using the actual loads as identified on the structure compared to the as-built, which is a completely new route.
Okay. All right, because I do understand then what you said correctly. That the drawings look correct, and you're using the as-built to move forward.
Exactly. We're relying on the ultimate model. It's purely the as-built and the actual load pressure rate design. Slide 20.
Just like to interject one thing. Part of the reason that you get the hundreds of hours of lockdowns in the containment was to look at what was attached to it, and then validate that against as-built drawings so that it was the field verification that was done. And we're also happy to do that for any modifications that we have. So we have extensive photographs and knowledge of what was found in the lockdown. That was primarily to make sure that the inputs to the model were correct. You could go through the most elaborate model in the world, but if we didn't have confidence that the inputs were correct, we wouldn't have any confidence that outputs were correct. That's why it's like get those in. What are the first items on the lockdown? We've got 4 simple lockdown teams. Lockdown teams are private, very those guys down. 4 simple different teams. down and make sure that separately they can, if it's required, that we take a seismic event and next time, we'll make sure that I will capture that as a thing.
Okay, I'll let you, one follow-up, just for my own edification. When we're talking about missile loads, are we talking about like turbine blade missile loads or impingement missile loads? No, we're talking about the weight of the structure that's there. That's right?
There are certain internal missiles postulated inside containment. Okay? A series of internal missiles. I'm not talking about turbine missiles, we're not talking about tornado missiles. Those are, the whole thing is protected by containment.
Okay.
Thank you very much for the comment.
That's smarter.
All right.
The design model we've constructed to represent the CIS is quite key to understand. It's more conservative than the requirements set out by the USAR. We thought it was important to use state-of-the-art principles, which are more conservative than the design methods that they would have used in the 90s. So we do go above and beyond the minimum requirements set out by the USAR. The key difference is USAR considers the CIS as virtual bridges, whereas our design model considers the fully justified flexibility of every beam and column, taking account of additional flexibility that a modern design would expect to occur during a maximum hypothetical earthquake.
Did the analysis in a vertical direction?
Yes. And we applied state-of-the-art principles all the way. This approach does cause the model to show a higher amount of stress in the beams and columns. Under seismic loading than would be the case if the model incorporated the USAR principle of vertical rigidity. Slide 20. This flowchart that you see here is an overview of the approach we've taken to the CIS research. We first performed a review of the design basis and licensing basis in order to make an informed decision and to provide the owner with options regarding methodology for the redesign project. We then performed numerous walkdowns of the CIS to help establish the precise as-built configuration, ensure that the design model is an accurate representation in terms of loads and geometry. Now, due to the discrepancies that were found between some of the older calculations relating to the CIS and the full Calhoun engineering drawings, it was necessary to firmly establish, as I say, the properties of the beams and the columns to establish the structural starting point. It was concluded that although some of the old calculations on record didn't match the as-built condition, this was a past document control issue rather than a design issue. And the full Calhoun engineering drawings are an accurate representation of the as-built condition as they match the actual construction drawings used to build the plant to an excellent degree. Two detailed reports are prepared to address loads, one for discrete equipment loads and one for distributed commodities, of which takes input from the walk-down report.
I got a question. You know, what's a model? You know, the big model?
We're talking about the frame model, not the very simplified bit more, but the overall frame model.
Can you give me the size? So he created the size of the model and discounted for the flexibility of the model?
Yes, sir.
What's the difference? Big model altogether.
It is a different bit model altogether. It is more conservative than the simple bit model in the use of.
Suppose it's more realistic.
Right, that's the intent.
Conservative is not so but think more realistic.
It's more realistic and based on the sensitivity studies we've done, it is considerably more conservative besides the rest. Oh, yes, just to continue, part of the reconstitution of the loads, account was taken for the smaller permanently fixed items such as smaller piping and HVAC to ensure that we had all of the mass accounted for. We had just a totally sound basis for both. In addition to S&A internal review, all of these foundational documents were reviewed by third-party engineering companies and OPPD engineers.
We talk about this a little bit, especially your discrete nodes and distributor nodes. You have outage conditions
bit more about the live load that you would use? I mean, take the time here. I mean, I don't, it's 2-3 minutes. You don't want to go into real detail. But how you define what live load you use for operating, what live load you use for the outage provision.
So we've completely reconstituted the load because the original design basis documents, you know, as I say, may have been an intermediate step, but the methodology that they took wasn't particularly rigorous in our opinion. They encountered equipment loads, live loads, which this isn't correct in terms of seismic modeling. You need to account only a small percentage of your live loads as part of your inertia, whereas for dead loads you want to remember all of that, and you want to make sure that all of that is accounted as a seismic load and multiplied by your seismic multiplier. So we wanted to accurately account for every only fixed piece of equipment in containment, and then look at the operating procedures and closeout procedures to make sure that we counted for everything. And during operation, there should be no live load. And so we carefully distinguish those outage cases from the operation cases, so that we've only got live load in the outage cases, which are maintenance activities, early maintenance activities. Everything during operation is dead load, and so this is why we've added the loads to account for commodities, which wasn't previously done, and up to 65.
So, talk about the commodities. Commodities bring the outage. Some of the commodities on the account of those in operation. Commodities, let's say piping.
We conservatively do operation loads during outages.
All right, thank you. Sorry, thank you for one question for you. Related to your work, the intake structure was reconstituted sometime in 2005 timeframe.
That's not something I've been a part of. Maybe someone else can speak to that.
I believe it was 2007. Okay, so it was. Are you aware of a similar walk-down procedure used in that competition? The reason I ask, recently with the taxi the raw water fund, design drawings and construction drawings, since we have the wrong concrete embedded, things specified in those two. But if that was the same procedure used in 2007, why would you expect it to move forward? So, I can answer that. Well, we appreciate the question, Chris. We are doing a root cause on the embeds for the raw water pumps to understand why they weren't of sufficient length in the correct design. We are reworking those, as you know, and we will do a full extent and condition of the cause in that root cause to understand why that happened. Certainly, it's a design and construction control issue that we're very concerned about, and we want to make sure that we address it holistically when we look at our cause and our extent and condition, these kind of conditions. Yeah, I appreciate that, Bruce. I just want to clarify that you need to find something in the root cause that there's a problem with the walk-down procedure itself, which then go back to verify that the walk-down that was done for the containment and vulnerable things that they. Yeah, if we determine that was a walk-down issue or a procedural issue for the walk-down, and then if we use the same thing, we would definitely identify that. Correct. Thank you.
This is Megan at the Region. Go ahead, Megan. Yeah, I think Chris brings up a really good point in that we appreciate that hundreds of hours are spent on walking down, visually inspecting and verifying the as-built drawing. But there's going to be a lot of stuff that is not apparent visually, like, you know, and the anchor rule for the raw water pump is a really good point. And so there may need to be some consideration for, are there other technologies out there that can be used to do maybe some spot checking on things that you can't visually see on the outside?
Yeah, we will consider
that it wasn't just one kind of error that was found. When you know, for this entire problem, it's not just that design drawings were incorrect. They're so widespread that I'm not sure we can just say, well, the core drawings are going to be more accurate.
I understand. So, goes from the 39.2, that's right. That was part of that, right? Not captured.
And like Bruce said, we're going through the
I'm not sure if someone's unmuted their phones or if they're hold music. Remember to mute your phones. We're getting some music on this thing.
If there are no further questions on this slide. This is on slide 22, a visual representation of the containment internal structure finite element model. The model you can see here consists of 167 beams, girders, and column sections. Each column is given a full set of code checks at 2 locations, and each beam is given a full set of code checks at 5 locations, both working stress design and no loss of function design, and all of those for 9 different load combinations. So a total of more than 13,000 checks are performed on the structure.
The total number of beams, columns,
And columns,
167, that's total.
that's
MIS.
that's total.
When you say code check, you're talking about GTC or code check outside.
Outside, external.
Let me ask you something about hearing a lot about columns and beams. The slab okay?
Slabs have been evaluated, and yes, they pass both working stress and architecture.
Is the slab in this?
That is not in the model.
So you have purely beam element here. There is no finite element like shell or plate.
That's exactly right.
Before we move forward to the Gothic model discussion, I wanted to take just a minute to talk about third-party reviews. This is where third-party reviews come into effect, or started coming into effect. OPPD is contracted search and funding to form a comprehensive third-party review design model. Agarwal and Sergeant Lundy, you spend a couple of minutes and step us through the third-party review process.
Good afternoon, everybody. I'm P.K. Agarwal. I'm project manager at Sergeant Johandy for the scope of the containment structures. As Bruce described, our scope is to develop the design for the modification and developing the modification package, both for the structural modification and the interference resolutions. So this is we are recognizing the process of putting the comments for the modification. Our scope also included third-party review of the analysis performed by Stevenson and Associates for the containment internal structures and the analytic analysis for the Richard Fisher performed by the Automated Engineering Services to give input the analysis of the containment internal structure. Our review was separate from and in addition to the detailed peer review which is performed by the respective organizations that are responsible for performing the original analysis. And our review focused on the criteria and methodology, awareness of assumptions, awareness of overall reserves, and it was rather intrusive in those areas. Our review comments are formally documented, and there is a formal document resolution process for all our comments, which are generated in the report. Questions? That's one question. You're going to be doing the modification design? model, or you're going to do your own model? I'm trying to figure out what the interface is. If there's different entities, I will explain this. Field instance analysis based on their model analysis provides to us the loads imposed on the columns which have to be installed, additional columns which have to be imposed to bring the containment into a structure within the acceptance criteria. So we get the loads for the column design from them. From there on, we can over it. And then we perform the detailed design of the connections, etc., and the rebar design for the columns based on the loads provided by students. Even associates, they're still the analysts. Absolutely. Okay.
One other item that OPPD picked up, we have contracted MPR associates to perform an independent review of the analysis, approach, and conclusions. Caroline's placement, MPR, did you step through MPR's approach?
Thanks, Brian. I'm Caroline Schlazen with NPR Associates, and in addition to the rigorous third-party review Virgin Lundy is doing for this project, OPPD asked NPR Associates to take a look at the work that's being performed by Stevenson and Associates. And our scope includes looking at the analysis approach methodology, looking at the results and the conclusions, and reaching some high levels about whether or not
What's going on? Whose phone is on?
Stuff describes differential pressure, the key input to the structural model. Differential pressure inputs were developed by automated common industry tool known as Gothic. Andrew Carmine of Automated Engineering Services illustrated the development of the Gothic model starting on slide 20.
I would like to tell you about the analysis.
I can't hear nothing.
In order to provide Stevenson Associates insight into differential pressure,
Why is there music playing? What the hell? Whose music is that? Oh, this went to hell.
correct. Those are the mass and energy releases. We use the mass and energy releases provided by OPPD from their design analysis, and we just input them into the Gothic model.
RC2A or the CPM.
Yeah.
Any breaks considered in those?
Yes, the brakes were considered in RC2 Bravo. We broke the RC2 Bravo up into 4 lines, 3, 8, 9, and 10 on the right there. Our RC2 Bravo.
Any additional questions or follow-up?
That is correct. Yes. 9, as described here, is just it's the volume between the 1028 elevation and 1046, and 10 is just between 1046 and 1056 elevations. We broke them down again just to be as accurate as we thought was necessary to get the floor, DPs, and Stephen Associates were. That is correct, between the floors.
None of the longer and more.
The walls are.
For the purpose of the calculation, get out of the Bible. Eric Alverson, the purpose of the calculation provide them the DP for them to use in their analysis was focused on those specific floors and that's where we provided the DP. It was a very focused, precise, and what they
What the hell? I don't get it.
For the pressure drop that we're using. We are on the order.
That don't make no sense.
Your design based now. It's replacing the pressure system.
going forward as part of the design change package. We're just looking at the containment. We have a separate thing going for the departments. The operability evaluation. The operability evaluation for thermal structures with any floor loadings. I'm looking at the departments around that. Other thing is that does this affect the commissioners? Control clarification. I'm going to talk about that later, but we don't believe it will. It is adding some volume into containment, which will the overall free volume, but I don't think it's going to have it. And you will have some, and we will have to redo that analysis as part of the interview. Absolutely. How much market do you have now over this time? I can't answer that right now.
We'll take an action to provide that information back. Are there other questions for Andrew?
These are time history. You give that to
That is correct.
welcome. On-time history or creating?
So I was going to discuss part of that later, but no, I mean we'll take that time history and we'll develop a dynamic load factor. In fact, develop a spectrum of dynamic load factors so it's just the natural frequency of the structure, and we'll take the peak of that, and that will be applied as a dynamic load factor.
slide 27, Russ will then provide an overview of operability evaluation development and current status. Russ?
Like the top model, brutal model. Well, that's a model that utilizes portal analysis, multi-service, preliminary results. So the 47B by column, 72 criteria. So working through and for relative strengths, primary. The areas that the 46 protection things, ventilation coolers, equipment, protector vessels, and lay down area. These can maybe be pointed out later. Areas of use. Note that all the beams and columns are operable under current outage conditions.
Could you define that? I struggle with your, I think I'm hearing you're outside your original design basis. And yet, is this a 9 part 9900 rated but operable, or is this operable?
It's non-conforming in that it does not meet both the working stress and ultimate strength design. But,
From the original licensing basis, right?
correct.
Okay. This is not open.
It requires both, and they'll be pointed out later in the presentation as well. Once we cover that, if you have more questions.
Hey, I'd like to then maybe ask the question clear enough. Can you define the term operable that you're using?
I think we have a couple of issues here. One is the mode of applicability doesn't even apply right now. No fuel limit. But I would call it non-operable if we have fuel limit.
Okay.
Right now, all the fuel is.
What would be the term you'd use if you're in mode 1?
We're going to talk about where we're at for the operating case. And
Okay.
we will.
All right, I'll wait. Thank you.
I can answer that question.
I know, but if you put it in here, it's really
Non-conforming but operable, but we have a couple of issues we're still working. We're going to talk about those. So, initial operability evaluation for the internal structure has been performed for both outage and operating conditions. The modeling methodology for operability is different from the design model in that for operability, we are looking to show that the structure meets loss of function criteria. Comparison, these differences between the licensing basis and the operability criteria will be discussed with the slides. The operability evaluation analysis will continue to be refined to ensure that adequate conservatism and design margin are maintained.
Russ, if I could, I'd propose a quick break at this point. We're about an hour and 20 minutes into it, and see a few people that are moving in their seat a little. So is that okay?
Yeah.
Is that okay if I propose a
10-minute break?
10-minute break at this point?
Everyone around, we're going to take a 10-minute break here. Please stand by. If you're the one with the, the hold music, would you please just mute your phone instead of putting on hold? The music is kind of distracting for the meeting. Thank you.
I think we can start.
Okay.
Yes, licensing folks, they get captured. So, go ahead.
Okay, we'll get started. Step back into the licensing basis and operability criteria with Russ. Russ?
Okay, we're now on slide 29. The design purpose for the internal structure for the licensing basis is to maintain the functional integrity of the structure with design basis margins under the most extreme load conditions such as the fact of hypothetical earthquake. For operability, however,
operability criteria use the same code, and that is ACI 31863. And I go back and I can appreciate you're doing a lot of modeling and evaluations with the modern code. I'm still looking at it and going, okay, now what does this mean for the FSAR and what has to change in your design basis? So you can help me here with where you're going in this year. They're trying to satisfy the operability piece, but I'm looking at saying, I'm not seeing how I'm not getting an invention out of this.
The approach we want to use is to stay with the existing license criteria to follow the ACI code requirements and to maintain the load combinations that are in the USAR. Basically follow that as our license basis.
And you saw the existing license, not on the list.
Right. That's a key distinction of the presentation. Well, actually, in this presentation, we're going to build a separate, here's where we're moving with the modifications to meet current licensing basis, and then there's the section we're just building here, the section we're describing is our operability basis. So there'll be two aspects of this presentation. One is targeted towards operability, the other modifications to restore us within licensing basis. And he's discussing right now the key differences between our licensing basis and our approach for operability.
Really, I don't see how I'm not going to get an invention out of it. Because it looks like changing some of your parameters, unless it's a source of current configuration, and that's it. It's validating what's there. It sounds to me like you're taking a clean, white canvas approach, coming up with some numbers of how you're going to try to respond to those as planning. Correct?
I think right now, Mike, it's a two-step thought process. One is non-conforming but operable, using the operability criteria, and our plans are to restore the full licensing basis margins in the future. And so at this point, we don't see a change required to the license. We may uncover one when we get deeper into the modifications and deeper into the analysis. So we have looked at preliminary margins, and we believe our peak pressure will be okay. We don't see that as requiring an amendment. We may uncover one, but if we follow the two-step approach, the non-conforming but operable case won't require a change, and when we restore the full licensing basis with the modifications, we believe we'll be in full compliance and won't require an amendment. Now, we've done a lot of work on the modeling. We're still working through the modification and the analysis piece, and Bernie's going to talk about the analysis piece. But we're certainly want your input if you see something we don't see in the license piece that we may need to talk about. I'm not a licensing expert, and I'll defer to my colleagues here. But I'm okay with, let's go through the discussion here. But it sounds like you're changing your methodology that you received the original license to. And I think if you change methodology, you might want to have a discussion on what that requires. I know where you're at, where you're headed, I hear that, but I sure do hear a lot of changes in the methodology tonight. Everything I learned over the years that has to do with method.
And we are aware of that requirement. If we do change the methodologies and we're not approved to use those, we understand that piece. Our 5059s are targeted at the modification loads, the active pressure, and which is the design basis earthquake and maximum hypothetical earthquake. And then on to slide 31, the licensing basis considers both working stress and the no loss of function load combination, whereas the operability criteria only looks at the no loss of function load conditions, and they have the same load combinations for the operability as what is used for the license basis no loss of function.
Sort of clarifying question here. When you say no loss of function, those particular load combinations are compared with output strength of 60.
Correct. Other questions? Okay. Doug Seymour will now provide additional details on operability criteria, including conservatisms that we are maintaining in our operability evaluation process, and we'll share operability evaluation preliminary results. And we'll continue on slide 33 and move the microphone down to Doug, please.
Thanks, Mark.
Doug?
So Russ just gave you some detail about the agreement we have between the licensing basis criteria and the operability criteria, and I'll now discuss that. I'll discuss that in detail. Russ gave you an overview there. The first example is ductility, where there's total agreement. Ductility is often used to show operability of concrete structures as permitted by industry standard building codes, nuclear building codes such as ASCE 4305. However, ductility can't be used for design, so we've conservatively neglected that in our criteria. There are really just two differences between the USAR specifications and our current operability criteria, the CIS. One is the use of concrete strength per the actual 28-day test data, and the other is the use of the no loss of function principle zone. The building code specified by the USAR does permit the minimum of rolling average of the actual 28-day concrete strength test data for design, which we are using to determine operability. But for design, we use the original 4,000 PSI as specified by the plant design basis document. And the operability model is consistent with the USAR in considering the CIS perfectly. The rolling average is a chronological rolling average of all of the concrete tests that were done at 28 days for the concrete used structure. And there are different criteria for working stress design and offset strength design. And for one, you take the rolling average of 3, for the other, you take the rolling average of 5. This produces a rolling average plot that's chronological.
How many tests?
I don't know off the top of my head, but
You don't have.
okay, we can take an action.
Yeah, the cylinder break. I'm assuming that's what you were talking about.
Exactly,
Your
cylinder
original
break.
construction.
Original
You did not do any core or anything.
No advertising at all. 28 days.
Yeah, the timing was very interesting on the, I think it was an information notice that came out in the last 3 months on using beyond the 28 days. We had originally considered doing that, but the complexity of taking the core borings, we decided to use the requirement. Average, and then the information notice came out literally the same week that we presented what we were doing. We do believe there's additional margins due to the age of the structure, but we haven't accounted for that in our effort.
Okay, moving on to slide 34. Another methodology often used to show operability is to allow a greater amount of moment distribution as later concrete building codes allow. But for operability, we've stayed within the provisions of the building code specified by the USAR. Also, later industry standard building codes permit significantly higher damping than that specified by the USAR. but in fact no additional damping is used in the operability model due to the vertical rigidity that's considered. Finally, these operability criteria do specify that demand must always be less than calculated capacity with no exceptions. Same as for design. All of the conservatisms presented represent real additional margin.
Your very first statement when you started, you said that this presentation is based on reaching agreement.
Agreement between the criteria set out in the USAR and the operability criteria. But my intent here is to show that we haven't deviated, in several different ways.
Okay. I want to make sure it wasn't agreement with me. So, the first bullet, are you saying you're not using moment distribution, or you
No, we are using moment for the code as per ACI 1863, but later concrete codes allow more moment distribution. We might have gone to that to show operability, but we haven't done that. Is there any further questions on the slide?
I'm going to ask you I may not know the answer off the top of your head, but the weakest link in this form, what is the interaction ratio? Before you did all this brutal analysis, when you did hand calculation.
In the region of 3.
Yeah. Then you did,
When we did hand calculations?
well,
No, hand calculations, more like, certainly there was a 2.4, I believe.
okay. So I'm assuming that was working stress design.
In general, yeah, working stress design is.
Now, you did the GT struggle. I'm trying to understand how you brought 2-point or 3-point interaction down below 1. What happened from A to B? So if you could please briefly describe, and you were talking about all of these conservatisms that you didn't consider. So I'm very interested to know what you did to bring those interactions down.
Well, there has been a full live load reconstitution, so there's been a full load reconstitution process. The original calcs used, they didn't consider a lot of the dead load within the structure, and they didn't consider size, the calcs that we have, and we completely reconstituted the load because we didn't have a sufficient basis based on these old discrepant counts to move forward, and so we've had to reconstitute everything. The loads have changed because we've increased the commodity loads up to 65 pounds per square foot, but at the same time we've decreased the live load to an amount consistent with how the structure is actually used. And
So did you, right now, are you limiting laydown area, live load?
yes, in one particular area where that beam is, where it has the high interaction ratio that I mentioned, that area is currently live load.
Is that going to change your heavy load path, safe path? There's the procedures, how safe load path. Is that going to affect any procedure?
Someone else might be able to
Yeah.
procedure.
Heavy load mount continuation and no specific.
Please continue. I mean, continue telling me.
Oh, okay.
I mean, I kind of deviated
Yeah.
from my...
Well, I mean that is a big consideration. There has been live load construction in one particular area where these most challenged beams are. They're beams B22 and B22, B22A and B22B, which are probably the most challenged beams in the structure. In that particular area, there has been live load production with the current house.
So you attack the demand side of it, because the capacity side, all I can see is 5.5 versus 4.
That's exactly right. For shear though, that is particularly helpful. Doesn't help you a lot with moment, especially when you have ductile failure, which always have ductile failure as far as I know at the moment. But for shear, it helps you a lot.
Now, I'm going to bring up another generic question. analysis. Let me give you an example. Let's say 8 beams, this floor, let's say it's under torsion, and you don't have loads sterile.
In every case where we have eccentric loads, we have closed sterile. This is something, we absolutely check all of those assumptions.
So the detailing of the structure supports your assumption
Yes,
for analysis.
Yeah.
Thank you. Comment on mobile cities and use of
So the Code of Record, the API 318.63, they permit up to 10% momentary distribution, and this is a very conservative amount of momentary distribution. And it is intended really to limit deflections to the same as what they would be under working stresses. When they introduced the USD, they didn't want results to be worse than they were under working stress. And so they have a very conservative amount of momentary distribution allowance. It's only up to 10%, and it only depends if you have the right amount of reinforcement ratios.
That was the presumption then that you're doing beam design, piece by piece. When you have the same structure, you're looking into all the again.
Not necessarily, because the analysis that we do introduce is an elastic analysis, so it doesn't take account of that redistribution that would occur with your the adjustments that occur within the concrete as loads applied. So
If you have someone's going to break you within that, you're not going to get that weight of that. You're not going to get any more redistribution beyond what. I understand if you're going to take the structure bit beyond that.
This is something that they permit you, and as you say, it helps you when you're in that critical region. But once you do get to that critical region, it helps you.
I understand that. Yeah, I understand.
So if you're at 1.05, it can get you down to 0.05. And as I say, it's a very conservative amount that was allowed by that original code.
This might be a penalty point, but less than or equal to 1 or less than?
But less than or equal to this. If the capacity, this is the acceptance criteria, and if the capacity is exactly equal to the demand, then you're okay. In check. There are additional safety margins that the code builds in to its criteria. Okay, moving on to slide 35. Summarize that the criteria that we use for non-operability are identical to those specified by the staff. Except the operability, we consider only the no loss of function design methodology. And design, we use the 4,000 psi specified concrete strength from the design basis rather than the actual 28-day test strength as allowed by the code 318.63, which we also use to determine operability.
Can I ask you a question?
Yes.
Dead load and live load. Notice that your working stress design obviously on dead load and live load.
Dead load, live load, and live load.
And when you analyze dead load and live load, what are the interactions? I'm trying to understand which load is it that's giving you the problem. Because right now you're saying I'm not going to do working stress design.
Right, exactly. As you know, working stress design is about approximately twice as conservative as ultimate strength in terms of the principles. And yes, and also it gives you 33% capacity increase under seismic conditions.
Which one is that?
Under the 318.63 code, it permits an additional 30, and this was used in the original design back in the 60s. When you add seismic, you get...
That's for commercial design.
Right. It didn't specify. There's no specification on the specification on that provision. And so, sometimes depth of size control, sometimes depth of size plus seismic control, depending essentially on the frequency of your structure and what your acceleration is for seismic. We do have failures to depth of line under working stress, and that's margin that has to be restored. But under a the ultimate conditions. It is important to note that you saw the load combinations earlier, and the working stress load combinations are bounded by load combinations found in the ultimate stress. So it's just a two-stage process to understand that we do consider those load combinations, and then the criteria used to establish that the equipment is still safe and safely supported. We determine that by the use of the load functions.
All right, thank you.
Moving on to slide 36. So, as we mentioned before, we like to keep track of conservatism used in the analysis so that we can have a qualitative idea of the additional margin that exists beyond the operability criteria. Primary conservatisms are, as was mentioned earlier, increasing concrete strength due to age hardening is conservative and for 50-year concrete, and can get 30 to 50% additional strength from age hardening, and we're not taking account of that at all. Ductility and increased damping for deep dynamic pressure loading is conservatively reflected, and as mentioned before, additional redistribution of moment, which the later concrete codes permit, is also reflected. The live loads applied to the stairs are conservative design, and additional damping and ductility for lateral sizing loads on beams which are laterally unrestrained is also conservatively reflected.
Actually, means there's no slab on it?
There's no slab.
There's a hatch or something? That's
Those beams,
on the torsion, I guess. If they're supporting any equipment.
if they're supporting equipment, yeah, extensions, then yes, they would be. But I don't.
How many of these beams do you have?
10. They are addressed separately, and the lateral sizing loads are applied to these beams.
Questions for Doug?
I think I have one more slide.
Go. Okay. Yes.
So yeah, the findings of the operability evaluation are that for the current ounces condition, all of the beams and columns are found to be operable. They meet the no loss of function acceptance criteria for operability. And for the normal operation load conditions, which include the loads that represent active pressure, the most recent full analysis showed that 3 beams exceeded the 1.0 interaction ratio. However, that analysis was based on a particularly conservative set of pressure results from the exotic pressure model, which Andrew presented earlier. And I understand that analysis is currently ongoing.
This is the 1.5 D load case, or the one that is
Yeah, sometimes it's that case, but
combined with E prime?
yeah, so sometimes it's the load case 1.25 OPPD and 1.25 pressure. That's the control.
So does that mean prior to restart, you're looking at either fine-tuning this analysis or making some kind of modification?
Absolutely. One of them.
I'll discuss that in the upcoming section, but yes, that's clearly the direction. Process is to complete draft final operability of calculations on December 20th. From there, we'll build our ongoing third-party reviews and owner's acceptance reviews, which will lead to the approval of the operability evaluation on January the 11th. This supports inspection activities in January. In parallel with these efforts, we'll continue engineering and construction planning. Moving to slide 40, I want to restate that we're dedicated to NRC inspection containment. Okay, sorry about that. Did I miss a question? Okay.
Excuse me, I missed asking it. The operability evaluation that once again, and you're going to do all this in 3 weeks or 4 weeks now, is meant to demonstrate operability, that term I'm using it loosely, for power plant operation in Mode 1.
Correct.
and shutdown. Obviously. It's operable in mode 1, it better be operable when you're shut down. The reverse may not be true. Okay.
Okay. So slide 40. So based on our product timeline, we propose using the week of January the 7th to present issue background documentation and conduct on-site familiarization walkdowns as desired at the Fort Calhoun Station. We're prepared on the week of January the 14th to support model reviews at Stevenson and Associates in Boston, and that we're offering to cover both GT Strudel and Gothic models in Boston with OPPD, Stevenson Associates, and Automated Engineering Services supporting those inspections if that's the most convenient to everybody to review it at that location. We're also prepared anytime after January 11th to support an operability evaluation inspection, and as demonstrated today, at any time, teleconferences or visits to Region 4, NRR, Boston, Fort Calhoun, we'll support those at your request at any time. Any comments or questions at this point?
No, I think maybe I started out earlier in the day. We're supporting the L350 panel here in headquarters. So the scheduling and the preparedness for the inspection activities will be done by Luisman and Doral here in this office. We'll coordinate with the L350 panel, see what.
And obviously,
I wouldn't count out us going to Boston. That seems like a short trip for somebody.
crowded.
We're offering certain weeks, that's just an offer. And Tony Vago, whatever, work all that out.
My mayor, because my action is going to have to understand because we're all that commission meeting, for Calhoun in this time period as well. What's going on?
Let me go back again. I hesitate there. The operability evaluations that you're reaching in January 11th, is that contingent on modifications to the plant as it exists today?
Not presently. We have some, there could be an interim step if we have some that we cannot analyze. We would go in, put a modification in to accommodate those few cases. We believe we can analyze them, but it's not contingent on other modifications. And we're pretty far through the analytical work. We have a couple of things, as per what Brian presented on the slide, that we're still
I
working.
think you got the last bullet there that captured that. Okay, good, let's go on.
Slide 41. Yes, Chris.
B22A, B22B, and B23 all on elevation 1013.
And all the columns are acceptable?
So slide 41 details our path forward after restart. We'll continue with our current design efforts using additional time to optimize our modification design. Understanding that, as Bernie discussed, adding columns will change the free air volume inside containment. Obviously, we want to be very sensitive to that and carefully evaluate the impacts of the reduction in volume as well as other interferences in general.
So I'm clear.
Yes.
You haven't identified any columns that you need to replace yet, to modify yet, before you make your operability call under some degraded but operable definition. However, there may be some that are required to restore the licensing basis.
That's
So
correct.
not need an amendment, it's up in the air.
That's correct. All under
I
evaluation.
think I understand it.
Okay.
In operability space, there aren't even any that are close under the operability criteria. Very.
Wait, Pat, I'm not sure.
No.
We're
talking apples and apples.
Okay.
Right.
So
Yes.
Pat was asking about would we be adding in columns. You addressed there were no columns that were showing failure, but there are beams. There's three that he
Right,
identified.
there's three that
And
we
if we can't analyze, we may have to put a column. And so that,
but to restore it to licensing basis, it's a lot more than three.
yeah,
that's why I understand.
yes.
That's why it's important to me that we understand the definition of operability. It's not one that I'm familiar with.
Okay. Can I just ask a quick question? But you have done some type of compensatory action to reduce your actual loads that you would allow in certain areas? Did I hear you say that?
Areas, yeah.
We have that control when we have the fuel flowing.
So is that only for the outage conditions, or is that also going to apply during operation?
It's only during the outage conditions.
Okay. That light loads will be removed from containment prior to restarting the plant. So that's part of the distinction between the cases for outage case and offline case. Okay. So the other actions we're taking, we're completing the engineering change packages, work instructions, the significant clearance orders associated with resolving interferences that Tom will show during his presentation that we'll encounter during column installation. And we'll also be purchasing materials to support future outage installations. So just back on the point about operability evaluation, as Bruce stated, we have current confidence that the operability evaluation will support operability, but if this is not the case, as Bruce discussed, we'll implement the modifications necessary to support the safe restart of the station. So operability is our primary focus, but we do understand that if these current analysis does not support operability, we will make the changes necessary to support operability and then implement the remainder of the modifications during future outages. Questions, comments?
No, I mean, we're not going to tell you right now. We've got a lot of work to do before we tell you, But the approach, I think we all understand it, and, I don't think anyone's in disagreement that it might be a feasible approach, but there's a lot of work.
Yeah, and we're clear on our end that we are preparing our site documents and we're making it convenient to perform any regulatory inspections required.
We did not come to a decision maker.
That is correct.
Right, absolutely.
That is correct.
Discussion we've had ahead of this meeting was if this was something my information, so we knew what your approach you give us some sense of direction and then.
Very clear. Yes, thank you. Okay. So based on our initial design model, sorry, Mike.
Vision having any reportability issues? Probably was. If you find things as you're going through these 50-50 eyes and doing these reviews that are outside the design phase.
We did have one, and that was having to do with B22 for the tip tanks. That was reported in August. Correct. All right. Are there any other questions? Okay. So moving forward, based on our initial design model, we've developed initial conceptual designs. Tom Bailey, who introduced himself earlier, is our project manager. Will provide an overview of design options and initial conceptual designs, and also highlight some typical interference challenges that we'll encounter. So moving on to slide 43, Tom.
Sorry, this is Megan at the region.
Go ahead, Megan.
Before we leave the operability subject, which it sounds like we may be doing.
Yes, Megan, the next
Okay.
presentation.
Okay. So I just wanted to clarify that I also understood there were a few issues that the region had dialogue with you guys on during the operability evaluations this fall, and I just want to clarify for this operability evaluation, you have gone back to the stamping that is specified far. You have not increased the damping.
That's exactly right, ladies and gentlemen.
Okay. So we are also using the design strength for the concrete at 4,000 psi, not an increased 28-day strength.
That's incorrect. So we're using on slide 35, Megan, we highlighted that we're for the operability case we'll be using 5.5 KSI, and moving on back to slide 33, the basis for that was our current license code, allowing for a 28-day strength test rolling average.
Okay.
Not using age hardening, but we are using the 28-day strength test rolling average as supported by our code of license.
Okay. So then on slide 26, my slide 26, you were talking about conservatism. You're saying no increase in concrete strength. That's beyond what could have been projected from the 28-day. But you are using a rolling 28-day average of 5.5.
That is correct.
Okay, and just for the record, I know it's already been mentioned, but I do want to echo that the information notice, the language in the NRC discussion part of that, does say that even though the code, ACI 38, allows that, the NRC does not find that acceptable to eat up that margin. So I know that's probably not something we're going to wrestle down today, but that's what the discussion language of the information notice says.
Yeah, and we totally recognize that, Megan, and the title of the notice does is specifically relating to design, and the failures of the parts that were identified were attempting to use that margin for design, and we're certainly not planning to use that margin for design. For design, we're using the existing design basis for 4,000 years, so only to show the operability of the plant that we're using actual 28-day testing.
Okay, it says the deviations from these allowables may require a license amendment prior to use.
It's going to be your design, yes, that's true.
Okay, so, and then the third thing I wanted to clarify was, I don't think we ever got to any conclusions on the alternate seismic criteria methodology. And that is what has been used for your operability and your modeling to support your operability. Is that correct?
That's correct.
Okay.
Oh, no, sorry, we're not using ASTM. I misheard. I was only discussing the ultimate criteria. No, we're not using ASTM. We use the USAR seismic spectra that are ground spectra that can be found in figures F1 and F2, appendix F.
And that's from the original licensing basis, not the alternate seismic criteria methodology that was adopted to the FSAR later.
Exactly. Yeah.
Okay, thank you.
Okay, I want to go back to the information notice because I'm not sure that we got clarity on both sides with Megan. That the information notice requirement really talks about design, and our belief is in operability we can use the 28-day rolling average, and I'm not sure we made that clear. I know, Mike, you were starting to talk, but I'm not sure that Megan understood what the conversation in the room was.
I'm sorry, can you just tell me who said that?
I'm Bruce Rash.
With,
Okay, I don't know if you want to elaborate or Marty.
Well, you just said what I was going to say, so I don't think nothing more I was going to add. Yeah, I don't have anything to add. Megan, we can discuss the information notice offline.
yep, definitely, thanks.
We call us Marty.
Thank you.
Okay, so before we move forward to look at some of our design options and modification developments, any questions on operability? You can always come back to it at any point in time, but I just wanted to give another opportunity to clear this section. If not, I've introduced Tom Daly, our project manager, and he'll highlight the conceptual design and illustrate some of the typical interference challenges. Starting on slide 43. Tom?
Thanks, Brian. Again, my name's Tom Billing. I'm the CIS Containment Project Manager. In a nutshell, I was basically appointed project manager for recent corporate development. I've got experience conducting major modifications, like construction management, pressurized equipment, also project manager. So I've got a little bit of an idea of how work is done. With that said, I've been project manager of Triple SRP 4 years. 3 of those 4 years. Well, planning process. 1 year. Vastly different now, which brings up project. Right now, I'm not sure if Brian may or not. We're pressing down a okay there?
Yes,
Yeah.
for operability, yes. I'll go through most of them.
Operability in what month?
For our current month. Yeah, so we're shut down, they're off with the headstand. You can put the headstand on the rear adjustable headstand.
That's accurate. I thought I understood that you had problems with supporting members for the stand now, currently. Don't worry about mode one, it's on reactive stand. There is an analysis that was performed in 2007 that we rely on to put the head on the head. And it needs whatever margins you have. Okay.
Any other questions? Following up, item first, general modification area number 4, general area, that's where we're looking at is located due south. Next slide. Sorry about that.
What are the loads at the equipment hatch? Is it just the hatch itself? What are the loads, just the hatch? I guess could you go back and show that picture? Talk to us. This is a plan view. Plan view on top of the different layers there. And you talk about at locations 1 and 3, you had some SI tanks there, SIT tanks, fixed ejection tanks. 2 is the vessel head, and 4 is your head. Those black lines give the impression that you have problems there, and that's why these are highlighted. You need to do modifications. Could be problems in the future. Go back and ensure you have margin in your original license, basically.
It's just general area. I just wanted to give
Just pick these areas?
indication that these are the general areas of the modification.
What are you going to modify? Maybe I could ask that way.
I'll get to that question.
Oh, you're going to get to it. All right, go ahead. Keep going.
That's fine. There we go.
Just breathe ahead.
Please don't do that. That makes me nervous. For this slide here, again, I want to talk about mods 1 and 2, general arrangement of those. I'm going to give details on those. I'm not going to go into 3 and 4 because I don't have to. So I would plan all 4 conceptual design that I was showing you. Mod 1 is 1013 elevation. So that's equipment hatch, valve, personal airlock, door, elevation. I'm looking down through the floor and the dotted line. What we proposed under the first modification is to install, we're going to 7 columns. And bear with me, there's 1, 2, 3, 4, 5. There's 1 column there and 1 column there under that cross beam. So there's 7 columns with 1 cross beam for mod 1 under 1013. So this will be installed on the 994 level, swing up and right underneath the bottom of the 1013. So we're cutting down the span of the beam. Just so we're doing. Right one. We're just going up now. This is on 1045. This is what's called our operating floor. How we get a set of stairs here. Ladder, once we go down, how we get out. But on the 1045 elevation, looking down, so this is actually looking at 1013 where we call it 2 columns. Column 1, column 2. Again, between 1013 elevation and the 1045 elevation. Right next to the Bravo and Delta safety injection. That's the major load layer on the floor elevation. In order to support those major loads, only 2 columns here and here.
Are these fine with the other 2, the 1013?
They're in line with this. They have to be in line. That's correct. I was going to say that. I want to find out.
Let's address the beam 22, what 22A and B and 23 or
Next one. Okay. Correct me if I'm wrong. 22, 23 are on the 1013 level. I'm sorry, right there. Yes, I will address those.
Got a question on 1013, but please continue. I'll ask later.
All right, and as we're going up for mod 1, this is on 1060 column for one prospect. So there's one column there, and there's another prospect. That picks up for 2 intersection. So these columns will be installed at the 1045 elevation at the bottom. We right next to, if you're familiar with our containment, we have our small size container are located. There's here. Columns are located outside of those two. Excellent. Okay, under mod 2, if it's just a general arrangement, we're trying to depict here is on the 1045 elevation. You're looking down through 1045. So, this is reactor vessel head indicator. And currently the reactor vessel head is supported by 4 pedestals, concrete pedestals. There.
for analysis being done as a sequential loading. In other words, the dead load stress is locked in with rebar. You can't take that out without jacking. I don't believe you're jacking.
No, we are.
You are?
We're jacking or preloading.
You're right. Yes, Jim. I can't tell you. I don't know how. Or did you? No, preload.
Connection between the columns and the beam. I guess that's the point, right?
See what's happening.
Alright. There should be more connection. I'm trying to develop the rebar into the beam.
No, we're not about that.
So it's not a moment connection.
No, it's not about connection. It's supposed to pin it.
He's just gonna drill and grab. Well, I may be asking a lot of my speak up.
First one is going right now to this first one. From the base plate, that you read from the column, 14, so they have to do.
One thing I want to, in 1013, you said the bottom is 9 feet away or so, 10.
994, yeah.
So the columns in that elevation is going to sit on your fill slab. Is on top of your structural slab, which has a liner plate. I'm assuming that's your detail. Normally in PWRs, you got a structural slab, you got your liner plate, and then you got a fill slab on top of it. So you're attaching the new column, or you're proposing to attach the new column to the fill slab.
All the columns that we're putting
I mean, that's not a structural slab. And you got to, so how is the load path going to be going through the liner plate, going through the structural slab, and going to the pile? I'm kind of confused how that's going to happen. You haven't got into that detail yet. That's my feedback. Taking action is how that load path is going to happen at the liner plate.
We'll capture that.
I understand. Well, you got to consider your entire shaded area, which you have your steam generator cubicles. They're anchored to the slab. They got couplers. And now you're putting a new column which is not attached to the structural slab. And this entire system has to work together because laterally your slab is supported by the box structure and also vertically. So there's an intricacy there.
Yeah, we will, yes, and I will recap these before we wrap up the meeting. I just want to say all these pictures are on the basement, but 994 looking out from the bottom, this floor right here, the bottom of it. This area in which the first column, or the column, is supposed to be. But the injection pipe right there, water pipe. While column interferences are a significant challenge, there are other containment analyses that require careful evaluation prior to modification of the containment internal structures. I think the question earlier on containment peak pressures, your question on the base mat interaction, further illustrate this point. And Bernie Van Zant will describe some of these analyses beginning on slide 55. Bernie?
Yeah, you kind of stole some of my thunder there, but the description Tom showed there shows a lot of field work going on, and we have an equal amount of analytical work that has to back all of that up. And have to, first of all, finalize the structural analysis in an internal structure and detail out the loads on all the beam columns so that S&L can start on their analysis and design of the columns. And two key issues there. One of them that you brought up was the interaction with the base mat, and also, as Tom discussed, we have a feature of these beams that we have to allow for, and that's for the jacking or preload on these columns, and that's going to be a significant design feature that's going to take some time to work out and make sure we get right. In addition to the actual structural analysis that we're doing, we're going to have relocation of significant amount of equipment, piping, which we'll have to do, redo hydraulic analysis on. We'll have to do seismic analysis for rerouted piping. The 4160 cables to the RC pump motors is an example of the cables. Conduits that we're also going to have to reroute and also re-support for seismic conditions. We also have duct work that there's one area where we have a duct that we're going to have to move or modify. That will also have to have an airflow analysis done to make sure we're not negatively impacting that, as well as look at any additional seismic supports that we may need for that. Once we get done looking at the interferences, we also have to design some additional structural supports, and then we're back to looking at the structural loads back into the structure. So we'll have pipe hangers that will be put to the structure, and we'll have to look at that as part of the analysis for the structure. There's other analysis that we're going to be impacting. We've already touched on containment pressure analysis. Right now, we checked, we've got 2.5 psi of margin on our containment design pressure. And the back of the envelope tells us we're going to be affecting that by about 0.2 of a psi, so it's not a huge impact, and we do believe we have margin, but it's still something we're going to have to revise and address that analysis. We also have high energy lines in this area, and we'll have to look at when we reroute equipment, are we moving anything into the target zone for a high energy line break, and that includes the columns that we're placing in the structure. Next is the containment sump analysis that was brought up. Water management. Another thing that we have is there's several of these beams that's going down to 994 elevation, which is the full path back to the sump. So we're going to have some impacts on the GSI 191 work that we did for the sump strainers, and that can get to be a huge issue too. So this isn't a total list by any stretch of the imagination. There's still quite a bit of other analysis that we'll have to look at. We believe these are the big hitters at this point, but we'll be going back to everything that we've touched as part of this analysis. Sump analysis would be mentioned. Yes. Pump strainer blockage. Flow of debris back to the pump strainer and what gets carried around the sump. We have to look at all of that, as well as, we're putting more concrete down there. Does that affect the chemistry? We have to go back through look at all of those. Are there any other questions?
I got one. Now, the spirit of our guidance that deals with graded non-conforming conditions and evaluating plausibility, is typically predicated on you're up and operating to find a problem. I do understand because of the complexity and the amount of time that it's going to take to figure out how you're going to fix anything. I understand the approach that you're taking, but in the spirit of our guidance, where it talks about correcting the problem at the voltage that not to exceed an outage. What are you looking at? Are you looking at, let's say hypothetically,
hypothetically, we agree with the OPPD approach. What is your plans for getting everything back to licensing basis status? Next outage after the restart?
Our plans are certainly predicated on completeness of safety. And from a schedule standpoint, I think we're prepared to say it can all fit in one outage. Certainly, if we can fit it up in the mobilization and demo price of getting the concrete pumping, just for example, and the labor ready is significant. So what we'd like to be able to do is move as many interference outage so that the construction activities can be easier and do through outages. And the commitments on time frame will come through Lou and company in terms of what the time frame would be for commitments on resolving the issue in total to restore licensing basis. But assure you that we do it in as timely a manner as we can with complete and safe analysis of the plan. I would say, 1 to 2, but I'm not ready to make the commitment. Who would have to make the commitment? We understand the restoration of full qualification, commensurate with safety and timeliness. In this case, it is complex. We have quite a few issues that when we start changing the design, we have to go reanalyze. If we can show that the current design is safe to operate for a cycle or two, we're finishing all of that analytics. That's what we would like. Tom talked about the major outage for the steam generator replacement and pressurizer and reactor head. That took 3 years of planning and a year to install. We believe this kind of construction is commensurate with that in terms of schedule and the complexity. Certainly is.
I do appreciate that, Bruce. I mean, personally, I think we'll have to have more discussions closer to restart. Whether it's the commitment process, whatever. But I think the NRC is definitely going to want to have a good understanding of what are the intentions to restore the solutions.
We understand. Yeah, question. Tell me just about meeting of my method. Again, doing that, as the plan that's our preliminary thinking, but we have a couple of issues that were brought up today that we'll have to consider. Certainly, when we do the modification, when we look at the whole impact of it, we may uncover something that we want to change our licensing basis. In that analytical work, we would have a long enough time frame to get it at the over feedback on it. Also, from the standpoint of the methodology, Brian can go through the actions, but if our methodology changes, then we'll have to come back and look at whether we're going to
I'll tell you what, at this point, prior to closing comments, I'd like to propose another brief break, and when we come back, I'll recap the actions that we are taking from this meeting, and then step right back into the presentation with closing comments and wrap-up comments.
Good. Those on the line will reconvene in about 10 minutes.
The actions that we've taken from this presentation, and what your needs will be covered in the inspection follow-ups, and they have a couple of distinct themes, so operability focus and some are future design focus, but we've captured these. And first one for Odd is considering the requirements for containment internal missiles as associated with R581 from both will coordinate and provide those details to the inspection team and make sure that
Also provide just the methodology, how you approach that.
in detailed methodology. Okay. Okay. And then there's so Ron raised the question for consideration of the design process, and so when developed, to share detail on new column to basement connection interaction, including specifics on basement design and load distribution.
Yeah, I think what we're asking for there is just, we'd like to hear the concept.
Okay.
We don't expect you to go out in a couple of months and come back with it. Like, the answer to be conceptually what are going into it. I would assume you can't do that design in a week.
Okay.
I could be wrong.
PK can work wonders. We'll provide that as it develops. Thank you very much.
I think that before restart would be a minimum. As far as the inspection, different details, I think Farad's going to be
Well,
right.
if they're not going to put the columns in before restart and they're doing operability, I don't know that we would need it before restart. It's something that we should consider, but I don't know that we need it.
I guess the concept of new column really affects future modification or doing that modification before restart. Doing something.
Understand? Capture that. And then Mike, just about a specific action, but just, I guess it is an action we're committing out of this meeting to continuing dialogue with the Region 4 office on the timing of our restoration to full license. Did I miss any?
I had a couple others. One was also that as you're going through too is having a sense for whether he's changed the methodology for a license and having to assure yourself whether they do or they don't. I'm sure this question will come up. And this may have been covered under the response back to or question Chris brought up, but Megan was hopefully asking that as far as your walk down procedures, it's possible some items may not be available to identifying for line of sight walkout, other technology to walk down first. So folding that back into the thought process, what you're looking at. I think that was another one that I captured.
Okay. So I'll capture the continuing to evaluate the potential for licensing request, and then from Megan's question, make sure we're looking at the walk-down process and feedback from raw water, but whether there's walk-down process. Okay.
I think speaking for the staff, in sessions that we've had, some very fruitful and productive meetings from understanding better what your proposal is, what your thought process is in looking at the operability or operable but degraded perspective. I think we understand it a lot better as what your proposal is. There will obviously be a lot more discussion. We look forward to receiving those and working with our region for the inspection team. The other, what's your actual analysis? So the other part too is we'll be taking back data. That you talked about in January as far as availability of both the analysis, and also being able to physically go out and look
interchange, as you said, scheduled a long time for this meeting. You opened it up to questions and we fired them throughout. So thank you very much.
Thank you for a preliminary meeting on this. I think covered a lot of territory.
One comment on maybe an outlier here. In particular, attention section. Annual chapter 99. That's really important. And there's context of life. Well, thank you for the opportunity. We know that we present a lot of information. We know this is more of a beginning than an end point. We'll continue to have the dialogue in the meetings. A couple of special thank yous when I asked for the logistics. Thank you very much for arranging the meeting. I know it was a short time frame for a lot of people, especially the caliber of folks that the NRC brought to the table. I want to reiterate that we are committed to safety, and so any decision making we have on restart will be firmly founded in safety. And if that means modification, we'll do modification. If that means alpha-val plus modification at a future date, do that. So it's want to be clear that it is founded in safety, and we clearly understand that. And we'll continue the dialogue on time frame for reestablishing the full licensing basis, safety margins, and full compliance. And we'll continue to support Chris in the inspection efforts. And I think if you read C13 and Part 9900, it alludes to regional support provided to the region by NRR in that specific last paragraph of C13, and that is fundamentally why we wanted this meeting, because we know the complexity of the issue and the reliance on the headquarters that you'll be expected. In the C13 paragraph, it doesn't talk about nonconformance. It only talks about degraded structures. So, in our opinion, the non-conforming section of Part 9900 also comes into play, even though it's not mentioned in C13. Typically, you would have two cases where you would have a non-conformance that you would apply operability, or you'd have a degraded condition. The Part 9900 C13 does not address the non-conforming piece of structures, but we believe it's covered in the non-conforming sections that are discussed in Part 9900. So that's, I think we need to take Part 9900 in totality and not just excerpts out of it, but we need to make sure that we are following the guidance. And if there's clarity that we can get or understand around that issue, we certainly want to gain that. Because it's not entirely clear why the non-conforming piece was down in that section.
Yeah, I'll tell you, Bruce, we'll be talking as we do our inspections, and obviously we have some serious disconnects. We'll be letting you know.
Right.
That's not the case, right?
Okay. So thank you for your time, and to all of our folks that came to support us, our vendors.
Thank you. Does anyone else here have any additional comments or questions?
Can the public
Did the public get a chance to comment or question?
Not yet. Getting to it now.
Thank
That
you.
concludes the business portion of this meeting. Before I open it up to comments, I would like to acknowledge some comments that we received during the break about not being able to hear. So I'll take that down as feedback, and we'll work on a better system for our next meeting. And with that, I'll open it up to the public for any comments for the NRC.
Thank you. This is Wally Taylor. I have several questions. First one is, were these structural and design defects present when Fort Calhoun was originally licensed back in 1973 or 74, whatever it was?
Can you repeat the question again, please?
Sure. Were these design and structural defects you've been discussing present back in
1973 or 74, whenever when Fort Calhoun was first licensed.
Yes, yeah, but I assume yes, the licensee isn't saying that. He's admitting to that.
Okay, and would these defects, or should they have precluded licensing if they had been addressed at that time?
We don't know the answer to that. We would just be speculating. This is Pat Island. I'm the director of the Division of Engineering. We would just be speculating. I assume if they were identified at the time, it would have been corrected or justified.
Well, I was hearing some comments about licensing criteria and licensing basis versus operability, which kind of inferred to me that these defects would be something that would have precluded licensing.
I can't address all of the discrepancies that have been identified today. As I said, that it depends. Some of those may have been able to be justified, and some may have been corrected at the time of the licensing stage.
And
years ago, I don't have the answer to that.
there was comment about weight supporting beams. What are these beams supporting, or what is the weight that's on them?
Now, we don't have the specific mass that's being supported by the beams. The beams are horizontal members that support. I think we heard today there's some tanks, safety injection tanks that may be supported. There's some ventilation equipment that may be supported by these beams, as well as the stand for the reactor vessel head that may be supported by these beams.
Okay. Has that been totally determined yet, or what?
I think the walkdowns, that we got a pretty good idea on what the beams are today, and the loads that are on them. Yeah, it's not in the presentation that I heard. Again, it's Pat Island, and I'm the director of the Division of Engineering in NRR. But I think we have that information, what beams are identified as needing to be addressed either through analysis or through repair.
I apologize if I didn't hear everything. It was the phone.
I understand. We took that as an action item. We don't usually use the room that we're in. It's a relatively small room, and believe me, 30 people have filled it up. So we apologize. We'll work on that, and we'll make sure that we have better audio communications. But there will be
some other housekeeping type questions. I gathered that OPPD had a PowerPoint they were presenting. Will that be available to the public somewhere?
Yes, that will be available this week.
On the NRC website?
It will be available on Adams. I can send you a copy as well, Mr. Taylor.
Okay, thank you. Finally, because we had a problem hearing everything, is this meeting being recorded, or will there be a transcript?
No, this meeting was not recorded.
We'll write a summary
Right.
of this meeting
Right.
and direct individuals how to obtain the handout that the licensee presented us in Adams. And you've committed to provide something in email on request, and you can do that to anybody that asks for it.
Okay. All right. Thank you. That's all the questions I have.
Thank you, Mr. Taylor.
Okay, my name's Laverne. A couple of questions. I guess he answered all those. The original laying of the concrete, because it's a dome structure, and they went around. Rumor has it there's a cold joint on one particular side of the containment building. And when I was hearing about the concrete analysis and that one woman talking about, better ways of looking into that concrete, have you considered a cold joint and looking into that, or is that something visual? Is that part of your 100 walk downs?
Hey, this is Pat Island. I'm the director of the Division of Engineering in the Office of NOI. And this is the first that I've heard that there's a rumor or some assertion that there's a cold joint in the concrete of the containment. And I would just ask the monitor here of our meeting to make note of that, and we'll follow up with you when we can get more specific details.
Okay.
And who is this speaking to me?
This is Laverne Tran.
Okay, Laverne, if you don't mind, can we contact you offline and get specific details on this?
Yeah, sure.
Okay, and do you have his contact information?
Laverne, can you send me an email with your information?
Sure. What's the email?
Linnea, Lynnea.
Do it again.
I'm sorry, Lynnea.
Okay.
Dot Wilkins. That's Wilkins.
WIOKINS.
LK. Yes. At NRC.gov.
All right.
I'll
Anyway,
repeat just to make sure you have it.
And then-
Lynnea. Dot Wilkins.
okay. Yeah, I got it.
Thank you.
And some more, the analysis of OPPD over the last 10 years, the rejection of the flood warnings given to them in 2004 and the NRC's 2010, and them, their engineering saying that it was fine, and then in 2011 having a flood and having this problem. The fact that these 18-month-old fixes have been breaking, the fact that OPPD omits information at these meetings when they're supposed to give you, what's happening in the plant, and I'm in the bathroom being told that, welds are breaking on uploaders, and those are just glossed over. And in fact that board members and vice president folks have made statements that there was no water in the building, and the NRC has very clearly said what water was in the building and when and where and why. I don't understand what difference has been made in the believability of OPPD and what they present to you. It just seems like they are constantly doing the bare minimum. This man says, no, we don't have to pour the concrete when it's brought up to him. He's brought up to him that maybe they should do a deeper analysis of concrete. We'll look into it. I don't. If I could have a nickel for every time I've heard OPPD say they would look into it, I would be a rich man. But I'm just saying that I don't see any management change except for Exelon coming on board and 2 new faces. So anyway, so I don't know, how the NRC still has a believable, after the years of OPPD fighting them when they've wanted to make modifications and upgrades and warnings.
Well, yeah, thanks for your comment. I will tell you, though, the NRC trusts and verifies. We've got a number of inspections coming up with a lot of inspectors, and, that's the way that we do business, and, we trust but verify. So.
But when you hear that man saying, I don't think we need to do that before we start, I'll look into it, this deeper analysis, I mean, doesn't that just give you misgivings? I mean, it does me as a normal person here, like going, well, he's going to look into it, oh, yeah, great. Why hasn't he looked into it? I mean, you're at the worst condition that a power plant could be in. A 0350 committee would have been red flagged, except it shot over to the 0350 committee. You would think if you're about to be fired, you might, step up to the plate and go the extra mile to demonstrate, oh yeah, maybe we should lay this concrete. Oh yeah, maybe we should take this extra step this woman is suggesting, instead of just looking into it. I mean, it's just, I don't know.
Yeah, thank you, sir. I do appreciate the comment.
Thank you, Laverne.
Yeah.
Does anyone else have any questions or comments for the NRC?
This is Charles Bostic. I have a question.
Okay.
I remember reading sometime recently this past year that the NRC has decided not to give out any new operating licenses until they had completed a review of their plans for long-term storage of fuel at sites across the country, and that this would affect some of the
applicants for new licenses on the East Coast. There's a couple reactors in Georgia and Florida or something that they were looking to get new licenses, but so those new licenses have been put on hold until they can review the fuel storage concerns, the long-term fuel storage concerns, and maybe the short-term also. And I also recall reading something that but this would not affect plants that already have operating licenses. What I'm wondering is, how does that ruling affect a plant that is in this particular process? If they have to adjust the license, as was mentioned today, due to if they have to redesign the support columns or whatever for the internal structures, there was one alternative that they would not have to modify the license, but there was a suggestion that they might have to modify the license for the plant. How is that affected by that recent ruling?
Okay, this is Pat Hyland. I'm the Director of the Division of Engineering in the Office of Nuclear Reactor Regulation. And I believe you're referring to the Waste Confidence Act and the ruling that has been passed several months ago and was adopted by this agency, the position that we will not issue any new licenses or license renewals pending resolution of the Waste Confidence Act and its application within the NRC. However, we will continue to review applications for new licenses. We will continue to review applications for license renewals. The impact of this potential amendment request to revise the existing license from, I don't believe is impacted by that position that the agency has taken. And I believe that on our public website, if you go to the front page and look up waste confidence, there'll be a better explanation by our expert, and I'm talking about our legal experts, than what I can provide you.
Okay, thank you. And so also, I had a follow-up question, and this. No, well, I guess you answered it. I think you answered it. That the existing licenses are periodically reviewed, and I might be misremembering the calendar, but I was under the impression that the existing Fort Calhoun license would be up for review. Well, I was thinking it was this autumn, but it might be next autumn. And so that would be in the same status?
Yeah, no, they've already been granted a license renewal, and that expiration for renewal, I'm told in the room here by my experts, is 2033. That would expire. However, on a periodic basis, the NRC does review modifications to the plant, and they're required to submit all the changes under 5059, which is our regulation, and then we look at them to assure that they had followed the requirements for any license amendments that would be required.
Oh, okay, I see. So the periodic review is for compliance with the license basis.
The very short-term periodic review, yes.
Okay, thank you.
Thank you. Are there any other comments from any members of the public?
Yes, this is Mike Ryan in Omaha, and just kind of a clarification for me in response to one of Wally Taylor's question. I think I heard the answer as being that one of the internal structural problems relates to a beam that's used to support the stand that holds the reactor head. Did I hear that right?
Yeah, this is Pat Hyland. Again, I'm the Deputy Director. I'm the Director of the Division of Engineering.
Right.
Just been promoted 6 years ago. Sorry, I'm getting a little tongue-tied. The component in question is a stand that when the plant is in an outage, they remove the reactor vessel head and it's appurtenances, and they set it on the stand. The stand typically is some 300 or 400, well, not, probably 150 feet away from the reactor vessel. Well, that stand must support the weight of the reactor vessel head. And what I've heard today is that they went back and they looked at the supports for that head, and they believe that they've lost margin on the head, and they have to beef it up with some additional supports.
Okay, thank you very much.
You're welcome.
Thank you, Mr. Ryan. Any other comments? Not hearing any. Double checking in the room. Everyone shaking their heads. That will conclude today's meeting. Thank everyone for their time and participation in this meeting. And I will email public feedback comments to those present on the phone. Thank you, everyone. Have a great day.